Dear students, most welcome in statistics class. Today our chapter is dispersion. What is meaning of dispersion? The degree to which numerical data tend to spread about an average value is called variation or dispersion. Or dispersion is a measure of variation of the items. Different terms used in dispersion. First is range. Range is difference between largest value and lowest value from the data. Largest value denoted by L, smallest value denoted by S. Difference between two is called range. Coefficient of range is L minus S divided by L plus S, and coefficient of range is always less than 1. Now we will discuss different measures of variation. That is, first is range. Second is mean deviation. Now what is mean deviation? Mean deviation is defined as a statistical measure that is used to calculate average deviation from mean value of given data. It is denoted by MD, that is equal to summation dy over n. Dy are deviation taken from mean or median or mode, and n is number of items given in data. In mean deviation, we ignore negative sign while taking deviation. Mean deviation is calculated from mean or median or mode. Formula for this is mean deviation is equal to summation dy over n, where dy is deviation taken from mean or median or mode, and n is number of items given in the data. Denote one thing: in mean, median or mode we denote deviation as dx, but in mean deviation we denote it as dy. This formula is for individual series when only variables are given. In discrete series, when frequency is also given, then MD is equal to summation f dy divided by n. Take deviation from mean, median or mode, then multiply with frequency, then take sum of f dy and divide by n. Here n is number of frequency, means total of frequency. In continuous series, formula is as same as for discrete series. MD is equal to summation f dy divided by n. But in continuous series, we take mid value from class intervals. And how to calculate coefficient of mean deviation? When mean deviation is calculated from mean, then coefficient is MD divided by mean. When mean deviation taken from median, coefficient of mean deviation is MD divided by M. M means median. When MD taken from mode, coefficient is MD divided by Z. Z is mode. Apply same method in all three series: individual series, discrete series and continuous series. Remember one thing: in statics, all data is calculated either from individual series or from discrete or from continuous series. These three series are backbone of the statistical calculation. Here is another formula when we calculate mean deviation without taking deviation. This is long method. In this, mean deviation is equal to summation x1 minus summation x2 minus n1 summation minus n2 summation bracketed, multiply with mean or median or mode, divide by number of items. Now what is summation x1? Summation x1 is value of variables greater than mean or median or mode. Summation x2 is equal to value less than mean, median or mode. Summation n1, number of items having greater than mean. n2, number of items having less value than mean. We will make it clear with the help of an example. Next measure of dispersion is standard deviation. It is also called root mean square deviation. Standard deviation is measure of amount of variation or dispersion of a set value. When calculated standard deviation is close to mean, then there is low standard deviation in the data. If value calculated of standard deviation spread out over a wider range, then there is high standard deviation. Now formula to measure standard deviation. Standard deviation is denoted by this sign. Formula for this is summation x square over n whole under root, where x square is deviation taken from mean, and square it. Note one thing, standard deviation is always calculated from mean. Or summation dx square over n whole square, where dx square is deviation taken from x minus mean. This formula is used when we calculate standard deviation from mean. When data items are very few and we solve or square it directly, means no deviation are taken, then use formula summation x square. Capital X means variable, small x means deviation taken from variable. In direct method, summation x square over n directly square each variable, then add them, minus summation x over n square and whole square root. In this, first add all the variables, then square it. Next is coefficient of variation or coefficient of variability, that is equal to standard deviation divided by mean into 100. Coefficient of standard deviation is standard deviation divided by mean. And now different method to calculate standard deviation when discrete series. The direct method, shortcut method, as we use to calculate mean, are also calculate standard deviation from same method. Direct method, summation dx square over n whole square root, here dx is equal to deviation taken from mean. Shortcut method, when we calculate standard deviation by assumed value, as we did in mean. Formula for this in shortcut method, summation dx square over n minus summation dx over n whole square whole under root, n number of variables, and dx is deviation taken from assumed value. If variables are very few, then do directly without taking deviation. Then standard deviation is summation x square over n minus summation x over n whole square whole under root. Here capital X means variables, n number of variables. When discrete series, in discrete series frequency is also given. Formula is same, but just multiply frequency with deviations. Direct method, summation f dx square over n whole square. F frequencies, dx deviation taken from mean, then square it, then multiply with frequency, n total of frequency. Shortcut method, summation f dx square over n minus summation f dx over n whole square whole under root. N is total of frequency. F dx square means square of dx multiply with f. Dx is deviation taken from mean. In continuous series, same method to calculate standard deviation as we do in discrete series. Direct method, shortcut method. Direct method, summation f dx square over n whole square root, n number of frequencies, total of frequency. Shortcut method, summation f dx square over summation f or n minus summation f dx over n whole square whole under root. In this we can also use step deviation method. If difference between class interval is common factor of dx, then step deviation method can be used. Same formula, summation dx dash square f divided by n minus summation f dx over n whole square whole under root into I. I is common factor in dx. After taking deviation, find a common factor, then apply this formula. Next is variance. Variance is defined as square of standard deviation. Same formula of standard deviation is used with every method of mean and do square of standard deviation. Means first calculate standard deviation, then square the standard deviation, and that will be called variance. So these are the different methods, formulas used to calculate dispersion, different forms of dispersion. Now we will discuss with the help of examples. First is range. Variables are given. Range, largest value 45, S smallest value 3, and range is difference between L and S, that is 42. Coefficient of range is L minus S divided by L plus S, that is 0.875. Next, when a discrete series is given, this is individual series. When a discrete series is given, means frequency is also given. We ignore frequency, we just take variables. Largest value 40, smallest 5, range is 35, coefficient of range is 0.778. Next is range in continuous series. In this series, we also ignore frequency, we just take class interval. This series is inclusive form. First make it exclusive form. Here is 20 to 29, 30 to 39. Make it is exclusive. Subtract 0.5 from lower class and add 0.5 in upper class. This is exclusive series, means continuous series. Then take largest value from exclusive is, that is 59.5, and smallest is 19.5. Take difference, that is called range, that is 40. Coefficient of range is 0.506. Next method is mean deviation. First in individual series, variables are given. First calculate mean. Total of this is 91 and mean is 13. Take deviation from mean, 3 minus 13, 10. Here we are not applying a negative sign because in mean deviation we have to ignore negative sign. So to this end, total of this is 34. Mean deviation is summation dy over n. Summation is 34. N is 7 number of variables. And mean deviation is 4.86. Coefficient of variation is mean deviation divided by mean, 0.374. When we calculate mean deviation from median, first calculate median, that is size of n plus 1 over 2th item. Here size 7 variables, so its size is 4th item. 4th item is 1, 2, 3, 4 is 14. So 14 is our median. Take deviation from median and total of summation dy is 33. Mean deviation summation dy over n, 33 divided by 7 is 4.71. Coefficient of variation mean deviation by m, that is 0.336. This is how we calculate mean deviation from mean and mean deviation from median. If we use direct method, in this first from mean, in this series our mean was 13. So summation x1 means value greater than mean in given variables. Greater than 13 is 14, 15, 18, 22. These are 4 values. So n1 is 4 and sum of these 4 values is 69. x2 is value less than mean. Mean is 13. In this series value less than 13 is 3, 7, 12. 3 values. So n2 is 3 and total of these 3 values 3, 7, 12 is 22. Then put value in the formula. Summation x1 minus x2 minus n1 sum n2 multiply with mean or median or mode. x1 value 69, x2 value 22, n1 4, n2 3 and mean is 13. By calculating we get 4.86. In direct method, MD mean deviation calculated from mean or by calculated with direct method, its value will be same, 4.86 and 4.86. direct method with median. Here median is 14, so take values greater than 14, that is 15, 18 and 22. Summation x1 is 15, 18, 22, total is 55, number of values 3, so n1 is 3. Summation x2 value less than 14 from the given variable 3, 7, 12, that are also 3 values. Total of this is 22 and 2, 3. Put values in given formula. Summation x1 is 55, summation x2 is 22, n1 3 and 2 3. Here median is 14. By calculation we get 4.71 as MD. Mean deviation from median is 4.71 and also mean deviation with direct method is 4.71. So this is first method we use in individual series. Next is mean deviation in discrete series. First we calculated from mean deviation from mean. Variables are given, frequency is given. We multiply x with f for calculating mean. Here mean is 18.06. Take deviation with mean, then multiply deviation with frequency. 8.06 multiply with 4, we get this. This is value after multiplying deviation with frequency. Total is 191.64. Mean deviation summation f divided by summation f. F is 36 and we get mean deviation 5.323. When we calculate mean deviation with the direct method, here mean is 18.06, value taken 18.06 from x, that is 20, 25 and 30. 3 values, so we take these corresponding value from fx because here frequency is also given. So we find value from this, but we take value from fx. 20, 25, 30 means 240, 175 and 60. This is our summation x1, its total is 475 and n taken from the frequency, that is 12, 7 and 2. Total of this is 21. Next is value of x2, value less than 18.06. 5, 10, 15. So corresponding values are 15, 40 and 120. And total of this is 175 and 2 taken from frequency 3 plus 4 plus 8. These are values less than 18, 3 plus 4 plus 8. By putting all these values in given formula, we get mean deviation 5.32. By comparing direct method and deviation method, we get that deviation method is less time consuming. So always prefer to use deviation method to calculate mean in place of direct method. Next is when we calculate mean deviation from median. From same statement, variables are given, frequency is given. For median we take cumulative frequency. First is 3, next is 3 plus 4 7, next is 7 plus 8 15, 15 plus 12 27, 27 plus 7 34, 34 plus 2 36. Total of frequency is equal to last class of cumulative frequency. M is size of n plus 1th item divided by 2, that is 36. N is 36, so size is 18.5. 18.5 lies in 27 CF, so median is 20. Mean deviation summation f dx divided by summation f. Take deviation from median. Variables 5 minus 20, 15, 10 minus 20, 10, 15 minus 25 and so on. Then multiply dx with f. 15 into 3, 45, 10 into 4, 40 and so on. Total of f dx is 180. Mean deviation summation f dx divided by summation f 180 over 36. F is total of frequency and mean deviation is 5. When we do the same with direct method, summation x1 value greater than 20. 20 is our median. These are 25 and 30. So take the corresponding value from fx. 175 over 60, that is 235. N is 7 plus 2. N taken from frequency. 7 plus 2, 9. And x2 value less than 20 from the variables 5, 10, 15, and corresponding value from fx is 15, 40 and 120. Total is 175. And n2 is corresponding value from frequency 3, 4, 8, that is 15. By putting value we get 5 as mean deviation. Next is mean deviation is continuous series. When mean deviation is calculated from mean, class interval are given, frequency is given, we will calculate midpoint from class interval. 0 plus 10 divided by 2 is 5 and so on. Then we assume a number from midpoint, that is 25, and take deviation. Then multiply deviation with frequency. 20 into 6, 120 and so on. Total of f dx, add the negative values and then add the positive values, we get minus 210. This is doing for calculating mean, because we know that mean deviation is calculated from mean or median or mode. So first we have to calculate mean. Mean is a plus summation f dx by summation f. A is assumed value 25 plus minus 200 and divide by 100. 100 is total of frequency, we get mean 22.9. Then come to table, take deviation for calculating mean deviation. dy is mr midpoint minus mean. We get these values. 5 minus 22.9, that is 17.9. Here ignore negative sign because we are calculating mean deviation. Then multiply dy with frequency. 17.9 multiply with 6, we get 107.4 and so on. Total of f dy is 657.2. Then calculate mean deviation. Summation f dy divided by summation f, we get 6.57. 6.572 is mean deviation. When we calculate mean deviation with the direct method, we need midpoint from that table and frequency, and multiply midpoint with frequency, we get fx. 5 into 6, 30. Find the values of or. First is value of summation fx1, value greater than mean. Mean was 22.9. from find from midpoint. 22.9 value greater than 22.9 is 25, 35 and 45. So we take value from fx 1275 plus 385 plus 180, that is total is 1840. And n1 taken from frequency 51 plus 11 plus 4, that is 66. And summation x2 values less than mean, we find from the midpoint. Values less than 22.9 is 5 and 15. So we take values from fx, that is 30 plus 420, 450. And summation f2 is 6 plus 20 34. Then fill values in the formula. We get 6.572 as mean deviation. In this we calculated mean and then find mean deviation. Now we calculate mean deviation from median. Our statement is same as for the mean. Class interval are given, frequency is given. We calculate cumulative frequency for calculating median. Size of n by 2th item. Note please, this is class interval continuous series. So we find median by taking size of n by 2th item. N is 100, size is 50th, 50 lies in 85 CF. So frequency is 51, CF is 34. As we know, we take CF of previous class, frequency of same class, and L of lower value of same class interval. So F1 is 51, CF is 34, L is 20, difference between class interval is 10. For calculating median, apply this formula. L1 plus n by 2th minus CF divided by F into I. I is class interval, n by 2th is 50, CF 34, F 51. By calculating we get 23.14 is median. Now take deviation from median. Here we need midpoint 515, deviation 5 minus 23.14, 18.14, and calculate all values. Then multiply dy with f, we get 649.52. Then put value in given formula, summation f dy over n, we get 6.4952 as mean deviation. Next we calculated mean deviation from median by direct method. For this we need midpoint, frequency, and product of FM, that is multiplying midpoint with frequency. Here midpoints are 5, 10, 15, and frequency is this. By multiplying we get FM. Then our median is 23.14. So for value of summation x1, take value greater than 23.14, that is 25, 35, and 45. So take the corresponding value from FM. We are taking FM because we are given frequency also. So first we multiply midpoint with frequency, then we take values from FM. These are 1275, 385, 180. Total of this is 1840. And for summation F1, we take these three values from frequency line, 51, 11, and 4, that is 66. Summation X2, value less than 23.14 median. These are 5 and 15. So we take 30 plus 420, that is 450. Summation F2 is 5 plus 15, that is 6 plus 28 is 34. By applying value in formula we get 6.49 as. Now we calculate standard deviation. It is always calculated from the mean. In individual series with direct method, variables are given. We find deviation from mean. So for this, first calculate mean. We get mean 30. Take deviation from mean. We get dx minus 5 minus 3, 1. Square of dx is 5, 25, 3, 9. And total of dx square is 64. Formula for calculating standard deviation is summation dx square over n whole square root. 64 divided by 5. By taking square we get 3.578. With shortcut method, assume value from variables, that is 31. By taking deviation with assumed value, we get this minus 6 minus 4. Then square the dx, we get 69. Summation of dx square is 69. Now formula for calculating standard deviation with assumed mean is summation dx square over n minus summation dx over n whole square 4 under root. Value of dx square is 69 divided by 5. Number of items are 5. Then summation dx is 5 by 5 square whole square root. By calculating, we get 3.578 as standard deviation. Coefficient of standard deviation is standard deviation divided by mean, that is 0.119. When items are very few, then we do by direct method. Take square of variables, we get square of 25 is 625, square of 27 is 729, and so on. We get total of 4564. Total of x is 150. Then apply formula summation x square over n minus. By putting value and calculating, we get 3.578 as standard deviation. Summation x square over n is 4.64. Summation x is 150 divided by 5 whole square root. We get 3.578 as standard deviation. In discrete series, when frequency is given, first calculate mean, then take deviation from mean, multiply x with f, we get fx, and mean is 17.68. Take deviation from mean, we get all values, then square the dx, then multiply dx square with f, we get 1001.84. Then apply formula for standard deviation summation f dx square over n whole square, we get 3.22 as standard deviation. Here n is total of frequencies. When we do with assumed mean, that is shortcut method. Assume one value from variable and take deviation, then multiply with frequency. Then for second column, take dx square, then multiply with frequency. We get these values. Summation f dx square 992. Summation f dx is 0. Apply formula standard deviation f dx square over n minus summation f dx over n whole square whole under root. By putting value, we get 18.21 as standard deviation. Next is standard deviation is continuous series, as same as for discrete series, but in this we get midpoint and other procedure is the same. This is class interval, take midpoint, frequency is given, multiply m with f for calculating mean. Mean is 36.4. Take deviation from mean, then multiply dx with f, we get f dx, and then first square the dx, then multiply with f, we get f dx square. Then apply formula standard deviation summation f dx square over n with when we doing with the direct method, and take square root, we get 10.02 as standard deviation. When we do with assumed mean, assume one value from midpoint, then take deviation, then multiply deviations with frequency, we get this 140, then do square of deviation dx, then multiply with f, we get 10,600. Then put value in formula summation f dx square over n minus summation f dx over n whole square whole under root. We get standard deviation 10.2, and coefficient of standard deviation is standard deviation divided by mean 0.28. So this is all about various method of dispersion. Please go through the video and take advantage of this video for preparing for dispersion chapter. Thank you.